This section is the introduction to Markov transition matrix. So a Markov transition matrix represents the conditional probabilities of the next state given the previous state. Here I will use the notation P sub AB. This represents the conditional probability of being in state B given that you're currently in state A. For example, if I set P sub 1, 2, that's the probability of being in state 2 given that you're currently in state 1. So a Markov transition matrix looks like this for a system that have only two states. We have P equals P11, P12, and then P21 and P22. So note that P11 plus P12 have to equal 1, because if you are currently in state 1, then you have to either transition to state 1 or state 2 in the next state. And same go for if you're transitioning from state 2 currently, you have to either go to state 1 or state 2. So they add up to 1. Here is representing those probabilities in the tree diagram. So this is the probability, conditional probability, of going from 1 to 1. It's going from 1 to 2, P12, going from 2 to 1, P21, and going from P2 to 2, P22. And it's important to note that these probabilities are conditional, meaning they represent the probability of going from one state to another, not the probability of being in a state. Let's look at this example. If Joe attended class yesterday, he has a 40% chance of attending class today. If he missed class yesterday, he has a 70% chance of attending today. Let attending be state 1 and missing be state 2. Find a Markov transition matrix for this process. So again, probability of P sub 1, 1 is the probability of state 1 to state 1. Since we said that state 1 is attending class, so we're looking for the probability that he attended class today and he will attend class tomorrow. Or he attended class yesterday, he will attend class today, same thing. So probability of that is 40% chance. If he attended class yesterday, he has a 40% chance of attending today. So the P11 is 0.4. Consequently, P12 have to be 0.6 because if he attended yesterday, he have to attend today or he has to miss today. So this is 0.6. P21 is the probability of state 2 over to state 1, which is the same thing as saying probability that he missed yesterday and he attended today. If he missed yesterday, he has a 70% chance of attending today. So this P21 is 0.7, and then consequently P22 will be 0.3. And here we can write out our transition matrix, and here it is. For a process with 3 states, it's going to be a 3 by 3 matrix that looks like this. We have on P11, P12, P13, and the next row 212, 223, and finally 31, 32, and 33. And the same idea will apply for more than 3 states. However, you probably will not be dealing with processes more than 3 states in this class. Here's a neat little k times likely trick. Sometimes you will be asked to find probabilities while given a statement such as that probability of one is k times greater than the probability of the other. So here the trick is to make them k to 1 and then put k plus 1 in the denominator of both. So let's say if Joe attended class yesterday, he is 3 times more likely to miss class than to attend today. P11 is a 10 then a 10, P12 is a 10 then miss. Here we have k equals 3, so we're going to put 3 plus 1, k plus 1, we're going to put 3 plus 1 in the denominator, and then set the smaller one equals to 1. So he's 3 times more likely to miss. So to miss is the big one, so 3 is going to be the big one. and 1 is going to be the small one, and 4 is going to be the denominator. So here we have 1/4 and 3/4. Sometimes you have to deal with multiple transitions. So let's look at this example. What's the probability that Joe will attend class 2 days from now, given that he attended today? So you can see this time of difference is that we're talking about 2 days from now instead of tomorrow. So here we have 2 transitions. And here again is Joe's transition matrix. And this time we're looking for the probability that he will be in state 1, given that he was in state 1 2 transitions ago. Or another way you can think of the same thing is that he will be in state 1 2 days from now, given that he is in state 1 currently. So there are 2 ways this could happen. For him to be in state 1 2 transitions ago and be in state 1 right now. He can attend 2 days ago, he can miss attend yesterday and then attend today. Or he can attend 2 days ago, miss yesterday, and then attend today. Here I've drawn the representation of what I just said, going from state 1 to state 1 to state 1, or going from state 1 over to state 2 back to state 1. These are the 2 ways that you can be in state 1 given you're in state 1 2 transitions ago. And since this is an either or, we're going to add up the probabilities. And to find the probabilities of each, this is very simple. If we just look at the first 2, this is going from 1 to 1. So the probability is P11. And here again we have P11. And for the 2 things to happen one after the other, these are independent events. So we can just simply multiply the probabilities. So here we have 0.16. And then for 1 to 2 to 1, we have here probability of going from 1 to 2 is P12. And then going back from 2 to 1 is P21. And again, independent events, we're just going to multiply the probabilities, which come out to 0.42. So to sum it up, the probability of 1 to 1 within 2 days is going to be adding 0.16 and 0.42, which is 0.58.